In this video, we're going to learn how to factor simple trinomials. Now, what is a simple trinomial? Well, a simple trinomial is a trinomial that you will see has a 1 in front of the x squared term. Now, this 1 might be positive or negative, but it's a 1. And so when we're looking at an x squared term, typically we'll see it like this. We'll see it without any value sitting in front of the x squared. There might be a negative sign there, but we'll talk about that in one of our examples coming up. But we know it's a 1. So it's a simple trinomial. The a value is equal to 1. All right, so how do we get started? Well, in a simple trinomial, the first thing we're going to do, and when we factor any trinomial, is we look for a common factor to begin with. And I don't see anything common that we can take out as a common factor. So we'll go ahead into our second step, and that is to take a look at this value at the end. I notice that the value is negative, and it's negative 3. So I'm just going to write negative 3 over here. And I'm going to focus on not necessarily the negative right now, but just the 3. And what I want to write down here are the factors of 3. What two numbers could I multiply together to give me an answer of 3? And I know that certainly 1 times 3 is our factors. And then other than that, there's nothing else. That's it. Okay, so the second step is this. I need to look at this middle term here. And I notice that it is positive 2. So now we shift our focus to the sign here. And this sign is negative. And that means that one of these values is positive and one is negative. Because when I multiply the 1 and the 3 together, I have to get negative 3 as the answer. Now, I just don't know which one is positive and which one's negative. And that's why we look at this middle term, this 2, as a clue. Well, where should I put the positive and where should I put the negative so that when I add these two terms together, I come up with positive 2? And I think you can clearly see that if we make the 1 negative and the 3 positive, when I add these two terms together, I'm going to get positive 2. And once we've done that, you know what? We're done. That's why they're called simple trinomials. I now know the two terms that make up this trinomial. And my answer is quite simply, I write two brackets, and notice that it's factoring, so we're reintroducing brackets and they are joined by multiplication. In the first one, I'm going to put x minus 1, and in the second, x plus 3. And we're done. There's the answer. And if you were to multiply this out using FOIL, so x times x gives you x squared, there we go. X times 3 gives you 3x. Negative 1 times x gives you negative 1x or minus 1x. Add those together, you get 2x, the middle term. And last but not least, negative 1 times 3, there's your negative 3. So if you were to expand out that binomial times that binomial, you would have the original answer back again. So you can always check your answer. Now, you might be asked, once you finish factoring, to actually solve for x, that is, state the values of x. So we can write here, if this was equal to 0, and this will be a common practice that we'll do, we would notice that x minus 1 will equal 0 when x is positive 1, and x plus 3 equals 0. Well, that's true when x equals negative 3. And how does that help us? Well, let's take a look at the graph of this function. There's the graph, and we can clearly see in this graph here that the x equals 1 is right there. And the x equals negative 3, well, it's right there. So when we set the expression equal to 0, and we factor it, and then we solve for x, we are finding the zeros of that function. Okay? So, simple trinomials have an a value of 1, and we can factor them quite literally in one step. Let's try another one. All right. So, let's factor this. Okay? And we'll see what we get. Well, to start out with, this does have an a value of 1, so I know it's a simple trinomial. I'm looking right in there. I don't see any value other than the negative sign. But that negative sign is a problem because there is a reflection happening here. And in order for me to accurately factor this, I'm going to have to first common factor out this negative sign. So that is basically a negative 1. And when I do that, the inside is going to change a little bit. So this is negative 1, and I'll be left with x squared. But notice how the 7x turns into negative 7x, and the negative 10 or minus 10 turns into positive 10. Okay? So if you have a negative sign outside in front of a simple trinomial, you must common factor that negative sign out first. Then you can go ahead and factor the inside. So let's do that. I'll go ahead and I'll leave this negative 1 out in front. And we'll take a look and we'll focus on the inside, and we'll follow the same procedure we did before. So here, I'm going to focus on the last value here, 10. I'm going to write it over here, and we're going to try and come up with the factors of 10. Well, I know that 1 times 10 is 10. 2 times 5 is 10. 3, nope. 4, nope. 5. There we go. Those are the only factors. Now I have to choose which factor to use. If I look at the middle term now, so let's take a peek. I'll use blue right here. The middle term is negative 7, and that means that when I add these two values together, I need to get negative 7. Now, notice how there's a sign missing in front of the 10. Well, it's not really missing, it's actually positive 10. That means that either both of these values were positive, so that you multiply a positive times a positive and you get a positive, or both of them are negative, so you multiply negative times negative and you get positive 10. So we just have to look at this middle term in blue here, and we just have to decide, oh, well, both of these terms to get negative 7 would have to be negative. And this is the pair that gives me that negative 7 that I need. So negative 2 and negative 5 added together will give you negative 7. So once I see that, I'm done. We know that, and I'm just going to put in my 2 brackets now. And I know that these are the factors. So x and then minus 2 and x minus 5. There is the answer for that expression factored. Now, again, if we were asked to state, for example, the roots of this quadratic, or solve it for x equals 0, and there was a 0 in front of here, I would just finish with the final step of saying, all right, when is x minus 2 equal to 0? Well, that's true when x equals 2. When is x minus 5 equal to 0? That's true when x equals 5. So we've got a root at x equals 2, a root at x equals 5, and this opens down because of the negative stepping value, and has a stepping value of 1. So let's take a peek at that, and sure enough, there it is. So we can see that our 2 roots of right there, positive 2, and right there, positive 5, are where it crosses the x-axis, and we can see that it has a standard stepping pattern. Okay, so that's how we can factor that example. Let's try one more. Okay, let's say we were asked to factor this expression here. Well, let's put everything that we've learned together, and we'll just try and do it, and we'll take it one step at a time. The first thing I'm going to notice is that the a value in front is not 1. So this doesn't seem to be, at first glance, a simple trinomial. But then, after I look at it just a little bit, I realize that, wait a minute here, there's a 2 out in front, and then we've got negative 10 and negative 48, and these are both even numbers. So the first step that I could actually do is to common factor out that 2, and I could leave x squared minus 5x minus 24 inside. And now when we clearly look inside the brackets, we've got a simple trinomial here. So let's go ahead and follow that same pattern. We'll look at the end term here. It's negative 24. I know that the only way that I can get a negative answer through multiplication is if one value is positive and one value is negative. So we'll look at the factors first, and then we'll try and decide where the positive and negative values go. The factors of 24, well, 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5, no, 6. Now we're back up the other side. So those are all the factors that we have. Well, which one do we choose? Well, let's take a look at this value here, this negative 5. If I look at these factors here, when I add them together, I need to have a value of negative 5. And remember, one of these factors over on the right is going to be positive and one is going to be negative. So let's look at 1 and 24. Even if negative 1, positive 24, that gives me 23. Negative 24, that gives me negative 23, so that's not it. But if I just glance down here, I can see that this looks really promising. And indeed, if I made the 8 negative and the 3 positive, that would give me negative 5 when I add them together, and it does give me negative 24 when they're multiplied together. Once I recognize that, I'm done. 2 times the first bracket is going to contain x plus 3. The second bracket is going to contain x minus 8. I could also quickly carry on and say, if this was set to 0 and I was asked to solve that, I could quickly say that, okay, well, x plus 3, well, that equals 0 when x equals negative 3, and x minus 8 equals 0 when x equals positive 8. I know this is a quadratic, it's a parabola, I know it opens up, and I know it has a stepping pattern of 2, and now I also know where it crosses the x-axis. Okay, so again, simple trinomials, just be careful. If it has an a value that isn't 1, well, take a look. You might be able to common factor out that value and turn it into a simple trinomial inside the brackets. Be careful if there's a negative 1 in front, factor out that negative 1 first, and then go ahead and treat the inside as a simple trinomial.